You're standing at the edge of a clearing. It's roughly 400,000 years ago. The grass ahead of you is tall, chest high, and it's moving. Not from the wind. Something big is in there. You know this because your whole group went quiet about 30 seconds ago, without anyone saying a word. You're holding a wooden shaft about 6 feet long, sharpened at the tip, hardened in a fire you made 2 days ago. You weigh maybe 130 pounds. The thing in the grass weighs close to a ton. And your job, your actual job right now, is to get close enough to kill it. No rifle, no trap, no cage. Just the spear, your legs, and the other 11 people fanned out on either side of you who are trusting you not to break and run. So here's the question that should be driving you a little bit crazy. How did they actually do this? Not in a vague, hand-wavy sense, but specifically, what was the strategy? What did they know? What did their bodies do that made any of this remotely possible? Because early humans were not built like apex predators. They were built like something that should have been eaten, and yet they were routinely killing animals the size of cars? Let's start with the physical reality, because you need to feel how strange this actually is before any of the rest of it makes sense. A woolly mammoth stands about 11 feet tall at the shoulder. It weighs somewhere between 6 and 12,000 pounds, depending on the individual. Its tusks can reach 16 feet. It can overturn a full-grown tree by leaning into it. And early humans were hunting these things, on purpose, repeatedly, across multiple continents, for hundreds of thousands of years. Now, the obvious question is why? Why go after something that enormous when there are smaller, easier options? And the answer is pure caloric math. A single mammoth kill could feed a group of 20 people for weeks. You don't have to hunt every day. You don't have to risk your life every day. One successful kill buys you enormous amounts of time, and time is what lets you do everything else. Build shelter, raise children, plan the next hunt. So the incentive was enormous, but incentive alone doesn't explain the method. Here's where it gets genuinely fascinating. The oldest direct evidence we have for large animal hunting comes from a site in Schöningen, Germany. In the 1990s, archaeologist Hartmut Thieme pulled a set of wooden spears out of a waterlogged peat deposit. They were balanced, carefully shaped javelins, with the weight distributed toward the front tip in the same way a modern competition javelin is engineered. They weren't crude sticks, they were precision tools, and they dated to roughly 300,000 years ago. Made not by Homo sapiens, but probably by Homo heidelbergensis, an ancestor species that was already solving complex engineering problems before our own species even existed. The implications of that are staggering. Ranged weapons meant hunters could wound from a distance. They could follow a bleeding animal, stay out of the kill zone, and outlast it. And that word, outlast, is the key to almost everything. We talked about persistence hunting before, in a different context, but it applies here in a modified form. Early hunters weren't always sprinting after prey. A lot of what they were doing was more like management. Drive the animal in a direction it doesn't want to go. Keep it moving so it can't rest. Wear it down over hours, sometimes across miles. Use the terrain strategically. Funnel the animal toward a cliff edge, a ravine, a narrow gap where it loses its maneuverability advantage. A mammoth is nearly unstoppable in open ground. In a canyon, it's a very different problem for the mammoth. We have archaeological sites that show exactly this. Bones piled at the base of cliffs, ancient kill zones where the evidence suggests repeated drives over generations. This is where cooperation becomes the real story, because none of this works alone. Persistence hunting, coordinated drives, terrain manipulation, all of it requires multiple people moving with a shared plan. And that shared plan requires something even more fundamental: communication. Not just grunts and gestures, but the ability to say, "You go left, wait until it reaches the narrow part, then make noise." That's a sentence with a conditional clause. That requires real language, or something very close to it. And the hunting record suggests our ancestors had this capacity far earlier than we used to think. You don't build a coordinated ambush by accident. You don't engineer a balanced javelin by accident either. Here's something that gets overlooked. The social structure of a hunting group was itself a survival technology. When you're going after something genuinely dangerous, the person who breaks formation gets everyone killed. So there's enormous pressure to maintain trust, to hold your position, to follow the plan even when every animal instinct you have is screaming at you to run. Groups that could do this survived. Groups that couldn't, didn't. Over hundreds of thousands of years, that's a very powerful filter. It may be one of the reasons humans developed such a refined sense of social obligation, guilt, loyalty. Those feelings weren't decoration. They were load-bearing. Now, here's the one that surprises people. Stone tools were not just weapons. They were butchering tools. And butchering matters enormously. A mammoth kill is useless if you can't process it efficiently. The marrow inside the long bones alone contains tremendous amounts of fat and calories. Getting to it requires specific stone tools used in specific ways. We find these tools at kill sites, and what they tell us is that early hunters weren't just killing. They were extracting maximum value from every carcass. They wasted almost nothing. nothing. The hide, the bones, the organs, all of it had uses. This level of systematic processing is not improvised in the moment. It's learned, practiced, and transmitted across generations. And that transmission is its own kind of technology. A grandmother who has processed 40 mammoth carcasses over her lifetime is a resource that has no parallel in the animal world. She knows which cuts yield the most, how long the meat keeps, what to do when the hunt goes wrong. Anthropologist Kristen Hawkes at the University of Utah developed something called the grandmother hypothesis, which argues that the extended lifespan of older female humans, well past their own reproductive years, exists precisely because their knowledge and labor increased the survival odds of their grandchildren. You don't see this in other species at anything close to our scale. The fact that humans live decades past reproduction is itself evidence that accumulated knowledge was worth keeping alive. Fire comes back into this picture in a very direct way when you think about large-scale hunting. Deliberately set fires were almost certainly used to drive animals in particular directions. We have ethnographic accounts of this from groups practicing traditional hunting well into recent centuries. A fire line behind a herd creates a pressure wall. The animals move away from it, and if your hunters are positioned correctly, you're suddenly in control of where a very large, very frightened animal is heading. It's terrifying to think about as a participant, but it worked. Fire also meant that meat from a large kill could be preserved, partially at least, by cooking. You can't eat a mammoth in a day, but you can cook portions of it, which slows spoilage and extends the value of the kill significantly. There's another layer here that doesn't get enough attention. Early hunters were extraordinary observers. They had to be. Knowing a mammoth's behavior, its stress signals, how it reacts when separated from its group, where it goes to drink, what time of day it's most sluggish. All of that knowledge was the difference between a successful hunt and a trampling. Modern trackers who practice traditional methods can read an animal's emotional state from footprints. The depth of a print, the angle, the spacing, these things tell a story. Our ancestors were doing the same thing. It wasn't mystical. It was granular, empirical knowledge built up over lifetimes and passed down across generations. They were scientists in the most basic and important sense of the word. What we also see in the archaeological record is specialization over time. Early stone tools are fairly generalized. But as you move forward in time, you see increasingly specialized hunting technologies adapted to specific prey. Thin, carefully worked points for piercing thick hides. Specific hafting techniques for attaching stone heads to wooden shafts. Atlatls, spear throwers that effectively extend the length of your arm and dramatically increase throwing force and range, appear by around 30,000 years ago, and possibly earlier. Each of these innovations was solving a specific problem created by a specific prey animal. The technology and the prey were evolving together. In a sense, because hunters who had better tools selected harder targets and drove the development of even better tools. And the targets were genuinely hard. Cave bears stood nearly 5 feet tall at the shoulder on all fours. Giant bison in North America weighed over 3,000 pounds. Irish elk carried antlers spanning 12 feet across. These were not gentle creatures. Hunting any one of them was a meaningful physical and cognitive challenge. The fact that early humans were doing this routinely across multiple continents against a rotating cast of megafauna that were often larger and more dangerous than anything alive today says something remarkable about what those small, fire-tending, spear-carrying groups were actually capable of.